Welcome back to School of Civil Engineering. This is Hedaetullah with another new video of Tekla Tedds. In this lecture, I am just going to show that how we'll design and analyze a combined foundation. So to do that, first of all, you have to select your course, code, country from here. So I'm using USA, and after that new. So from here also I'm using Tedds calculation USA US unit. You can change that as per your requirement. So after that I'll just go here concrete, and from here concrete, or I'll just go foundation. From here I'll just go footing analysis and design. Okay, and from here suppose if you click here for combined footing, you can use that calculation to remodify, okay, as per your requirement, right, as per your requirement. Otherwise you can use that option, footing analysis, and after that you will change that as per your requirement, right, you will change the data as per your requirement. So I'm just using that option, footing analysis and design. So continue. So from here you have to select which types of footing, steep or pad. So obviously that is pad based, and from here sort of the length. So length will be considered. Consider that your one column to center point of one column to another column. Okay, from one column to another column distance from center to center, that is 12 feet. Okay, that is 12 feet. So I will consider 15 feet a 15 feet foundation, and width I will consider that is 4 feet. Initially I will just consider that, and depth that is 12, and if required I will just increase that. So here the density of concrete 150, I mean 150 psf, and sorry cf pound per CFT, I mean unit weight. And here the dead load structures if you have any, and live load structures if you have any, you can input there. So when it's done, now I'll just go for soil properties. Now bearing capacity, what is the bearing, gross or net? So I'll consider gross, and here 3 kFF, it's okay, you can change that as per your soil condition. Density of soil is 120, and angle of internal friction, this is 30. If you have, you can add that, I mean sorry, you have to add that. And angle of base friction, if you have, you can add that, otherwise uncheck here, right. And also if you have resistance of soil against sliding as per Rakhine column and user defense, you can use that option. So for columns you have to provide here the angle of wall friction like that. So I'll just use no. So when it's done, I'll just simply click OK. Now the main part is okay. After that I'll just go ahead for calculation option. Okay, so here the design combo, okay, for service load combination. So here actually you know that for design foundation we have to use service load, not ultimate. So here you can select any of that version of code. Okay, so here I am using ACI, and also as I am using only dead load and live load, that's why I will not use another load from here. Otherwise you can add any load, any other load from here. So I'll just click OK. And also if your factor of safety against overturning, I'm considering 1.5, and also factor of safety against sliding, then 1.5 also considering. So it's okay. Now everything is okay. Now first of all we have to add first column here. We will first column in that side and second column in that side. So I'll just click add. Just see, this is the position of first column, but I will consider our that side column is 10 inch into 10 inch, and this column are situated 1 feet away from the face. So how will just give that value? Position in x direction, position in x axis, then how will be it? Consider that it will be this, they have 5, and so we simply just give it 12 plus 5, that means 17. Just see here, I mean the column face will be 1 feet away, column feet will be 1 feet away from that site. And here when it's done, I will just provide here the, and also if you need that, you need to change the position of that column in y axis, then also you can change that data. So if you just give her 18, suppose 18, just see it will move in that direction a little bit, so I'll just use 24. Okay, and in that side, for that side similarly, in that side column will be 12 feet away from that column face, okay, from that column face. So how will use that? I will first of all, for that column face I will just use load, and also remember there is 17 inch, there is 17 inch. So what we'll do, here I will apply dead load for axial load. So for dead load I will consider that is 25, and for live load I will consider that is 40. And if you have load, horizontal load, you can add here as per your requirement. If you have moment, then you can add here, moment on base you can add here. So for column 1 I will just simply click OK. So this is the value for column 1, and obviously click here preview analysis result. So I'll just click preview analysis result for that condition, okay, for that condition. Okay, so when it's done, now I'll just go for that side column. Okay, so I can click add, click not edit, click add to add our second column. So this is our second column, and one thing remember, our that first column was away, from that column face. What will be now our second column? Actually I'll just use calculator, and our one column to another column distance from center to center, that was 12 feet plus, and there have 17 from that center to that face. So sorry, that 17 plus, also you can consider 12 plus, I can close that, 17 divided by 12 and plus 12, so 13.4166. okay, so I am just copying that, copy, and simply I will just give variable in x direction, paste here, and then click anywhere. Sorry, that is inch, we have to provide that data in so in inch. So I'll just clean 12 into 12 plus 17, 161, that is sorry 161, maybe that is 161, yeah, 161. So see, this is your second column, and I will increase the column size little bit. How much? That will be in x direction, that will be 10, sorry 12 into 12, consider that is 12 into 12. So it's done. This is the way to draw a commanded foraying, and after that I will consider that first that side. Okay, for that side our dead load will be 30 and our live load will be 40. Okay, consider that will be 40, and after that simply click OK. Now see what happened, it's calculating, and wait for some time. Now see, this is okay, and as loads have applied it in that side, right, load have applied it in that side, that's why our load distribution done by everywhere, every base point. So here the applied value is 2.7, but we have our soil capacity is 3, so it's okay, right, it's okay. So everything is okay, everything is okay. When it's done, now I'll just go for next. For design or analysis is okay. Now I'll go for design and I'll simply click here review. So here automatically a value have calculated 10 number 6 bottom bar 6 in center to center and 10 now 6 bottom bar center to center. So here everything we are seeing that, but maximum reinforcement spacing bottom, that is not okay. Okay, or required 18, but we have provided 19. Okay, 19.2. So we'll just go for change that. We'll go for change. First of all, we'll select materials. The materials is 30, and this is, we have to select from here bar tensile yield strength, and here the materials compressive strength. Then okay, and also nominal cover, that is 3 obviously. Okay, and wait for some time again. So it's done. Okay, it's done. When it's done, I will just design option. We are using ACI 31811 design code selected. Okay, sketch view, this is for reinforcement diagram, this is for shear diagram, and this is for moment diagram. And also for x-axis, this is the moment diagram for x-axis, this is the reinforcement diagram for both x and y axis. They have no problem. This is for x-axis, and sorry, y-axis, and this is for x-axis. Okay, so and when it's done, for x-axis we are seeing that they have several failure. Okay, they have several failure. So what I'll do, I'll just go for reinforcement detailing. I'll just go here, and here the area of top reinforcement provided 4.4, but required 5.7, right? 5.7. So I will just apply number 6 bar, it's okay, and also I will increase the number of bar little bit, 15 bar. When the bar is 15, just see the 14 bar. Okay, if we consider numbers, bar number 7, and if I come here till 10, number 10 bar, number 7, 10 bar, 4.5 inches center to center, and for bottom required is 1.50. for the x direction reinforcement, actually 1.50 required for bottom. Okay, but we have provided 4, so what we can do that, we can use number 5 bar. Okay, number 5 bar, sorry, okay, number 5 bar for 5 bar here in x direction, so has 10.3 in center to center for x direction in bottom, and for top they have no requirement of reinforcement for y direction. Okay, and area of y bottom reinforcement, that is required 3.49, but we have provided 4.4. so we can do that, we can use 5 number bar, and we have to provide more bar here like 15. Okay, like 15, because here 12.3 in center to center. So now it's okay. I'll just simply click OK and see what happened here. So everything is okay now, right? And for y-axis, so also everything is okay. So when everything is okay, we are seeing that 5 nonce, 5 nonce bottom bar, and 7 nonce top bar, 4.5 in center to center, and this is for x direction, I mean in that direction, in y direction actually. So also if I just again go, this is not okay, 6.5, so again we have to increase little bit, so it's okay, 11 bar. If we provide 11 bar, then it's okay. So for x direction, okay, bar in x direction, so again I will just come and so it's now okay. and here see the utilization value. Utilization value is also okay. And in x direction, okay, we have to provide total for bottom. You have to provide 5 bar, 10 inch. After 10 inch, 10.3 inch center to center distance, and for top we have to provide 4.1 inch center to center. But for bottom we'll provide more bar than it, because it is required. Actually, why for bottom it's required less bar, and for bottom we required 15 numbers 5 bar. Okay, so 12.3 inch. So why required less bar? Because this bar, when a deflection will occur, then at middle, if we see that diagram, shear diagram, just see at top maximum shear will create from moment. At top maximum moment will create for y direction, but for x direction, just see here the maximum moment will create at the minus negative moment, right? A negative moment will create. Okay, and for shear, just see here 0, here shear 0, and that point the shear is maximum. Clear that side? It's showing the value. Note shear 1 for x direction, for shear diagram. For reinforcement, if you see here for reinforcement they have some issue. So if you also click here, what utilization under moment negative, the required is provided 1.8. so utilization ratio for reinforcement is okay, but for moment we have some issue. So I'll just go back, and here I will increase the width in actually I can increase the depth 18 inch, and after that I will see it's okay or not. And also I will increase that size in 15 into 5, and I'll go next. Now see for reinforcement diagram, for shear diagram this is also okay, for moment diagram this is also okay, positive moment this is absolutely okay, and for x direction this is okay or not. So for x direction only shear value that is not okay, so I will just go here for moment, for shear, and for reinforcement. So here I'll just go for reinforcement change. So what I'll do, the record is 1.9, but we have provided 1.5, so I will do 6, 7, okay, 8. If we provide 8 bar, then okay, it's also okay. And for bottom, the bar is 12, record is 5.3, we provide 4.4, so I will do I'll use number 7 bar. Okay, so now it's okay. I'll just click OK and see is it okay or not. Now it's okay for x direction, reinforcement, for shear, for everything, and for y direction also they have some problem for y direction. So I'll just click, and this is okay, and I'll just go back, and again I'll increase 24. Okay, then I'll go next. I'll go next. Now for x direction that is also okay, for reinforcement, for shear, for moment, and for x direction actually again they have some problem. How to do? Again I'll just go for reinforcement, and here I'll increase area of bottom reinforcement, it's the 8. I'll use number 7 bar, so this is okay, and I'll just click OK, and I'll wait till that value for x direction. So for y, for x, So even they have shared two-way column 1. Okay, share two-way. So again I'll just go for reinforcement. I think it's okay, 5.5. so if I, this is number 7 bar, and even if I provide some bar, 20 bar, 9.1 in center to center. Now see it's okay or not. Now it's okay. Okay, so in this way you are able to design and analyze your section properly with maximum economical way. So thank you very much. Stay connected till next video. And before that, just finish here and you will get just your report perfectly. Okay, so here is the report. So if you go down, here is the moment diagram, share diagram, moment diagram, share diagram, and also as the detailing of our reinforcement. I mean here the reinforcement detailing. So if I just zoom little bit, just see here is the reinforcement detailing, right? So in this way you are able to use that software perfectly without any problem. So thank you. And also we have to provide the reinforcement in y direction in top, because for bottom here requirement, that's why we have to provide reinforcement in top. So you have to just right click, calculate and provide that reinforcement. So thank you very much. Stay connected till next video. So thank you very much.